Okay, so welcome back, and today we're going to do another example and introduce some other definitions and concepts. So in this example, let's say that we have a current. Okay, so we have three wires that are entering a junction, and so we have the currents of each of the wires, I1, I2, and I3. Okay, and they're coming into the junction here. And so we have this equation. This is based on called Kirkhoff's law. And basically stated, it says that the algebraic sum or total of the currents of a junction must equal 0. Okay, so we get I1 plus I2 plus I3 equals 0. Okay, so this is an equation in three variables. Okay, now obviously one or two of the currents must be negative for this to add up to 0. Okay, and then we have another example of a couple of forces. So we could have a couple of forces acting on a beam, let's say, and we could have this relationship here. That 2 times the force 1, 2 times the value of the force 1, plus 4 times the value of force 2 equals 200. And this is what we call standard form. Okay, standard form is, or general form, is in ax plus by equals c. So instead of having the equation equal to 0 and having everything to the side, we can write it this way. Now this is also called a linear equation in two variables, right? We've got an x variable and a y variable. Okay, the other one was, right, so if we look at this one, so this is a linear equation in one variable. This is a linear equation in two variables. Okay, so now in this case, since we have two variables, this means that for every x variable, there's going to be a corresponding y variable. Okay, and so that means the solution to this equation is a pair of numbers. Okay, so we're looking for a pair of numbers that makes this statement true, and that's going to be a solution, whereas in this case, we're only looking for one variable, which in this case is going to be negative b over a. And so the solution here is one number, right? So where in this case, it's going to be a pair of numbers, okay? And it depends on what x is. So y depends on x, right? So if you make x 1, that's going to determine what y must be. Okay, and that's it. So let's do an example.